There are two DC values. So first you can see the green wave is what is
Reading.
the signal that's going for our voltage, and the yellow wave is the signal that's altered by our hardware solution that's going to help us with frequency. So first we're sending in a wave with a 1.5 volt offset, which will be displayed as our DC value in the terminal right here. So there you can see a 1.554, pretty accurate. And now I'm going to change it to 2 volts offset, and that should change the DC value. So there's 2 volt offset, and our multimeter reads a DC value of 2 volts.
B peak to peak at 1.05.
So now for our AC, we'll do a 3 volt peak to peak sine wave with 1.5 volt DC offset at 500 hertz. So here's 1.5 offset. We're already at 500 hertz, and now we're going to change our peak to peak to 3 volts. So there's 3 volts peak to peak, and our terminal reads, there's our peak to peak value of 3 volts, our frequency at 500 hertz. So next we'll do a 1 volt peak to peak sine wave with a 0.5 volt offset. So
Explain it to you.
Oh, and then also we have our graph bar chart with our DC, our peak to peak, and our RMS. Here's the scale of the voltage from 0 to 3.3 volts. So next we have a 1 volt peak to peak sine wave with a 0.5 volt offset. So that's 500 millivolts. So 500 millivolt offset. Oh. 1 volt peak to peak sine wave, and that's at 1000 hertz. So we can crank that up to 1000. So 1000 hertz, 1 volt peak to peak, 0.5 offset. As you can see, our values are still correct. 1 volt peak to peak. Next we have 1.5 peak to peak with a 2.5 offset. One volt peak to peak, 2.5 offset, 1000 hertz sine wave. You can see our terminal measuring 1 volt peak to peak. Here's our offset, looking good. And then next we're going to go to a triangle wave. So our ramp and frequency of 50 hertz. Hertz. 1.5 offset, 3 volts peak to peak. So 1.5 offset, peak to peak, 3 volts.
You get that. You explain that as creating an algorithm,
Okay, so triangle, 50 hertz, peak to 3 volts, peak to peak, 1.5 offset, and you can see we're reading our offset of 1.5, peak to peak,
Okay, so what are you trying
close to
to
3 volts, 50 hertz. A couple more, so we have now 1 volt peak to peak.
That's how you're gonna do.
I think this is
Alright, so what's your plan for frequency?
so 10 hertz, all the way down to 10. Need to make sure what kind of wave this is. This one's a square wave, so I'll change this to square. Square. 1 volt peak to peak with a 1 volt offset. Or 1 volt peak to peak with a 1.5 offset. So peak to peak. 10 hertz square wave, 1 volt peak to peak, 1.5 offset. And here you can see our 1.5 offset, our 1 volt peak to peak, 10 hertz. All right, so now we're going to test out our frequency with a sine wave.
Oh, I see.
That's going to
That's
be
what the code's supposed to be
a
doing already, right?
1.5 offset, 3 volts peak to peak.
But we would keep
With
something like that.
our maximum frequency. So we're going to take this to about up to 1,000 hertz. So we can read up to 998 hertz with accuracy on our terminal.
98.
998. Hertz. And now we're going to show our low frequency with a square wave. Square wave. 3 volt peak to peak, 1.5 offset again. And we're going to bring that down to our minimum frequency. Three volts peak to peak. 1.5 offset. There we can display 7 hertz as our minimum frequency.
Do you want to explain the hardware? Just real quick.